picked this problem because this kind of brings into play your week 1 and 2. It does not bring power factors, I believe, because I did a balanced load, but it does bring a Y-connected. So here's the thing. You have a balanced Y-connected voltage source with a certain voltage and a certain kVA. So it goes without saying, this is the source, pick this as your S base and V base. Right out of the gate, just go and pick your S base and V base. The source is connected to a balanced delta load. Can you guys read? I mean, is this big enough? Okay. It's connected to a balanced delta load. Your source was Y, your load was delta, and the Z delta is given as 30 ohms with an angle of 40 degrees. Keep in mind, just because you have an inductor or a capacitor here doesn't mean you're going to have harmonics. It's when it is non-linear and unbalanced. So just keep that in mind. Impedance between the source and the load is ZL for each phase. And I want you to calculate the per unit and the actual current in phase A of the line. So there are a few things that you have to keep in mind. You have and I'm just making this up as a Y source, but on the other side you have a delta load. I believe it was week 1, lecture 2 that we looked at a Y and a delta, and I told you whenever you see a delta, unless you really want to do a delta, go ahead and convert this, but in industry most of us just convert a delta to a Y, and that's how we start our problem. The second, you have to be careful. I never mentioned a 3-phase, so to say, but it's a Y connected voltage source. So that should tell you, and the second thing that should tell you that they're talking about a 3 phases, it's A and B. It's not an A and neutral. It could be E or a V. So EAB is 480 volts. And when they talk about an impedance between a source and load, that's this line impedance that they're talking about. Can you see this impedance between the source and the load? They're not talking about the load. And I should have done a better, sorry. My bad, there was something. Yeah, they try to call it line. Z line, and that's this guy, 1 angle 85. Voltage here is 480 volts, 0 degree, and this Z delta, just one side, is 30 angle 40 degree. Question for you guys, how do I convert this to a Y? Does anyone want to try that? Should be in your printed notes or the PPT that I sent you somewhere. Not a whole lot of interest going on, so. So going with the easy ones, I chose my S base because you have to choose an S base, and I prefer to choose the S base that's on the source side, and it's like 10 kVA. I chose my line to line voltage as my V base, 480. Keep in mind, even though there was an angle associated with it, when I choose my base, I shouldn't use the angle. The next, I want to convert my Z delta to ZY, because I want to have a Y to Y rather than have a confusing system where there is a delta on one side, there's a Y on the other side, or if it's a delta delta, I just prefer to have it in YY. So knowing that the load is at delta, the easy way to do this is Z delta is 3 times ZY, which means, no real math here, but my ZY is actually 1/3 Z delta. And then my preference is to go and figure out the Z base immediately, because doesn't matter whether I'm on an exam, just want to get the low hanging fruits. I already have defined my S base and a V base. It's easy enough for me to go ahead and find my Z base. So what's Z base? What is Z base? V squared base line to line divided by S base 3 phase. Keep in mind we are in a 3-phase system. So 480 volt, no angle here, divide by 10,000, and that gives me and I should have had a volt here and a VA here, and that leads me to 23.04 ohms. Keep in mind this is still my Z base, it's not my per unit. Actual unit divided by my base gives me the per unit. Actual units you figure it out from the problem. The base is what you derive by choosing S base and V base, and then you reach your per unit. So I just figured out my Z base, easy enough, 480 volt square divided by 10,000 VA, and then I figure out my first per unit for the class, well, not first, third per unit for the class. So what's my actual Z load here? I believe at this point it was nice if I could. Now I'm going to find the Z per unit associated with this line. Keep in mind I fixed my S base from the source, my V base from here, and I just in the last sheet derived my Z base. So maybe we should just keep a track of all the numbers here. So this was my S base, my V base was 480 volts, no angle. I base I haven't. I just figured out my Z base. You guys mind telling me what the Z base was that we just calculated from your pictures or notes?
23.04.
Oh yeah, I have it here. Yeah. I just figured out my first Z base, 23.04 ohms. And now you do need it, but I'm going to find a per unit for this guy. Think of this for a minute. I used a voltage and an MVA from this side, and I figured out some sort of a Z base. And I don't see any sort of resistance here, but I was able to pick up an impedance. And I'm going to use this impedance throughout the system because it's just one voltage system. I don't have a transformer here. And very shortly I'll be converting this guy into a per unit and this guy into a per unit. I've already converted 480 into a, it's going to be one, but still, I already have a V base and an S base. It's just a matter of time that I can convert this into a per unit. So I'm trying to convert my line, transmission line, so to say, to a per unit. So what's my actual value? It was 1 and 85 degree, right? I just divided by the 23.04, and that's it, boom, we're done. So you end up with some sort of this guy with an angle per unit. Keep in mind, per units will have the angle. Base values do not have an angle. Never put an angle to your base. Whatever is your base, it has to be just be a real number. But when you come to your per unit, they will have an angle. So all that I'm saying is, it's not enough, like you want to give enough info to a per unit that someone who actually wants to come up with the real number, they can just multiply and get it back. If you take away this angle portion and just give them ZPU as a PU of this magnitude, they'll be able to come back and figure out the actual value, but they will lose this 85 degree. So always a per unit always has a magnitude and some angle. Not every now and then, every problem will have something with a 0 degree, that's fine, but don't take away the angle from here. Your base, on the other hand, is just a number. There are no angles associated with it. And that's true for S base, V base, I base, Z base. So if you're doing a problem and there is an angle associated with your base value, you are messed up. Oh, not sure if you guys can read this, but I did put base has no angle, but has units. Do you guys know if your homework was graded? Not yet, okay. So we just figured out our first per unit for the Z of the line. Now we are going for the Y, load system, or the ZY. So you have your load with a 30 and a 40 impedance of 30 with an angle of 40. And that was a delta system. To get into Y, I divided by 3, and that pops from this guy. ZY is 1/3 Z delta. So I took my 30 impedance with an angle of 40 divided by 3, and again I use the same Z base. So once you get going, it's pretty easy. It's just a matter of practicing a few problems and then you are good to go with this. So my ZY PU, or the load PU, is 0.43 with an angle of 40. You may not have noticed this, but I just want to call you, want to get your attention to this. You had some weird number like a 30, 40 and then a 185, but now look at the per units. This guy times 10 is this guy. So you start coming into some sort of a numerical game where you are able to understand the load is actually 10 times that of line in terms of per unit. So this was 0.434 and this is 0.43. Maybe I should have taken a few more decimals, but yeah. Now, for those of you who have sort of paid attention, but yeah, it was okay for me kind of thing, here's what's going to trip you if you have not been looking through the notes very carefully for the first 2 weeks. I gave you a line-to-line voltage, and it was 480 volt with an angle 0. A line-to-line voltage with an angle of 0. Shouldn't have shown you guys. Okay. So my line to neutral, this is pretty simple enough. You just divide it by √3, you get the magnitude. Right? But I have to ask you this. Where is this negative 30 coming from?
Why do you want to say the delta?
Is that the leading lagging?
Yeah, but from where? So you're on the right track. Go ahead.
That's all I got.
Okay, something is leading, something is lagging.
Difference
Okay.
between the voltages is
Oh, it's lagging.
Is it
Sorry,
from-
sorry. Yeah.
Is it phase
Yeah.
and line?
Yeah.
Is it the difference, is it that difference?
Yeah, so keep in mind, you are in a Y system. So you have the right idea, and I think once you look through the notes, you should be able to get it. Maybe. Anyone else on this side? You guys have been pretty quiet. Yeah, go ahead. No? Remember the first class that I said that math is easy, but it will get you if you don't pay attention to the basics. So when we started this class, and I think I'm going to run into trouble today by not completing this, but still. You had an A, you had an E, and you had a C. This I said, hey, let's take it as 1, 0 degree. Your B, I asked you to take it as 1 and negative 120. And the C, I asked you to take it as 1 and positive 120.